Hello, ladies and gentlemen of geometry. Welcome to section 4.5, Isosceles triangles. I'm Mr. West. Let's go ahead and get started. So here, first off, recognition to one of my former students who drew this amazing picture. I just want to thank Victoria for that, so thank you, Victoria. Awesome moose. So isosceles triangle. What is an isosceles triangle? Well, an isosceles triangle is one that has two equal sides. So let's go ahead and write two equal sides. Okay, so if we have a diagram here, one of the first things that we need to recognize that these need to be the legs. These are the legs of the triangle, and they need to be equal. Okay, an isosceles triangle is always in the setup where two of the legs are equal, and then it has some other features which we're going to talk about right now. Now, if it's not the leg, okay, there's two legs obviously, and then there has to be a third side. The third side is called the base. This one has a different measurement than the legs. Okay, now these angles here to the left and right of the base, okay, so it's touching the base and also a leg. Okay, each of those angles touches a base and also a leg. These are called the base angles. So pretty self-explanatory. They're base angles because they touch the base. Base angles. And both of them must do that. Now there's always a third angle that doesn't touch the base, and this is called the vertex angle. So this is the vertex angle. And those are all the features of an isosceles triangle. Now, very important, the legs are the same. Base angles, what do you suspect those are going to be? Okay, take a prediction. We're going to find out very soon how they are related. So first off, we have the isosceles triangle theorem. If we know that, and if you want, you can write this along, but just knowing it from the diagram, these two things, you don't really need to write this out, as I'm going to do right now. But if we know that AC is congruent to BC, okay, so those two sides, then what else do we know? Then we know that, and this is what we're talking about with the base angles. Let me go ahead and draw them in. Then we know that A is congruent to B. So angle A is congruent to angle B. Now, what's another way to identify this? Let's say you're not sure. Well, importantly, always identify, again, the base. So the base is this line in blue because it's not one of these two sides. So once we identify the base, we can say, okay, I'm looking for the angles that touch the base and touch one of these congruent legs. It's angle A and B. Also keep in mind that these two angles point to their corresponding congruent side. Okay, so that's another way to think of it. All right, let's move on. So that was isosceles triangle theorem. Now you don't need to know, in my class, you don't need to know the name. The only time you'd use something of the name is when you're doing proofs, and you could say isosceles triangles have congruent angles or something like that. Converse of the isosceles triangle theorem. Okay, so if we know. Now, if you want to memorize the name, that's fine, but I just wanted to give you a heads up. As long as you get, in my class, as long as you get somewhere close to representing the idea with the name, that's fine by me. Converse of the isosceles triangle theorem. So before we knew that the sides were congruent, therefore the angles are congruent. Now we're saying if the angles are congruent, angle A is congruent to angle B, then we know that the sides are congruent also. Let me use, I'll use blue this time. So now we know that AC is congruent to BC. And if you just want to use the diagram and not write the letters, that's fine by me. These are your notes, not mine. So obviously if they have two equal angles, then it has to have two equal sides also when it comes to triangles. Here's the isosceles midsegment theorem. Now let's say we got this situation going on. We got the congruent sides, okay, so we know it's an isosceles triangle. Then we have this little segment drawn here with these two angles congruent. Well, first off, if those two angles are congruent, then this is also a bisector. So we can go ahead and write that in. This is going to be a bisector. Now, what does that mean, bisector? How am I spelling this? Well, there we go. Figured out my problem. I don't want text options. I'm not going to tap again. Okay, so that's a bisector. Now, a bisector means what? A bisector means that it splits this into two equal segments. So now we know, oh, where's the if and then? Oh my goodness, no if and then. So if we know that DC bisects. Now, this is not only a midsegment bisector, but it's also an angle bisector. So we'll say angle ACB. And we need another condition. AC is congruent to BC. Now, it's already in the diagram. If you don't want to write this, you don't have to. But so we know that it bisects the angle, the vertex angle. Okay, so again, that's the vertex. And that it's an isosceles triangle. Then we know that, did I write if? Yes, I did. Then we know then AD is congruent to DB. Or let's call it BD. Let's be consistent. So there we go. It splits that into two equal parts also. Corollary to the isosceles triangle theorem. So corollary means like an additional support, another offshoot, a branch of the isosceles triangle theorem. Okay? So before we said, if we know that two sides are congruent, we know it's isosceles. But what if we know that three sides are congruent? We got this side, and this side. So real quickly, I'm going to write what I've been doing. I'm going to say if xy is congruent to yz and is congruent to xz, if you want to say zx, that's fine too. Then what else do we know? Well, we know that all the angles are equal to each other. So angle x is congruent to angle y is congruent to angle z. Now, quick pop quiz. What is this triangle? If we know that all the sides are equal and all the angles are equal, what is this? This is an equilateral triangle. Okay. All sides equal, all angles equal, it's equilateral. Now corollary, we're just going in reverse again. Oh, corollary to the converse of the isosceles triangle theorem. Boy, bring that one up at the dinner table for conversation. That's a doozy. So if we know the angles are equal, so we have angle x congruent to angle y congruent to angle z. Then we also know that the sides are congruent. So this is true for triangles. If we know all the angles are equal, then we know all the sides are equal also. And what we're going to see later on in later chapters is the size of the angle corresponds to the size of its opposite side. So that's something important to take into consideration. But we're going to learn about that later. Okay, so we know all the sides are equal. Now let's apply it. This is kind of like the best part. Look at these cute little acorns. We have this triangle with some missing information, but we do know that we have congruent sides. So what do we do from here? Well, the first thing is we should easily identify that x is going to be equal to 4 inches, just because it's a given that it's equal. Okay, it's congruent. Now, one thing I want to note, this is marking the angle here. I don't like that. This angle z should be here. Before that line means that it's equal. So definitely erase that if you have that. Okay, it should be just z, not that little equal angle. Otherwise, it'd be 70, 70, 70. That doesn't make sense. Okay, so the second thing we notice is because this is an isosceles triangle, these two base angles, okay, this is our base, need to be congruent. So again, let me label this real quick. This and this are both base angles. Okay, so that makes y equal to 70 degrees. Now this is the tricky part for most students, but once you get it, it's not as bad as you think. Now we need to find this angle. This is our vertex. So finding the vertex angle from the base angles is not too bad. So what we're going to do here is we're going to say, all right, we know that 70 plus 70 plus our our vertex angle, z, is going to be equal to what? It's going to be equal to 180. So what we need to do here is we need to do just combine like terms. So we get 140 plus z equals 180. Make this different color. Okay, and then I'm going to subtract 140 from both sides. Minus 140, minus 140. And I get z equals 40 degrees. So there you have it. Z equals 40 degrees, and you just set up a simple mathematics summation problem, and you get your answer. Z equals 40. Okay, now we have a different isosceles triangle. This time we have it equal to 5 degrees, not 5 degrees, 5 feet. Okay, so we know that z is also going to be equal to 5. It's an isosceles triangle, so we're going to say 5 feet. there. Now we have to find the base angles. Now we don't know the base angles, but we know the vertex angle. So these are the base angles. Okay, so how do we do that? Well, now we have a different problem. Now we know that x plus y plus our vertex angle, we'll call it 40, equals 180. But how do we solve when we have two variables? Well, here's the thing. X is going to equal y because these are base angles and we know that they're equal to each other. So what we can do is we can just say, all right, let's just call this guy x. Okay, because x equals y, we can substitute x in for y, and then we have our problem. So x plus y plus 40 equals 180. So we substitute x in for y, and there we have our new problem. Now we can combine like terms. We get 2x plus 40 degrees equals 180 degrees. So now we subtract 40 from both sides, and we just have a nice two-step equation here. That's not correct. 140, sorry. And we divide by 2. And this is the exact same triangle as before in terms of angles. X equals 70 degrees. So then we have if... Oh, I'm sorry, I labeled z wrong. I'm sure you guys noticed that right away, but I did not. So we have x equals 70 degrees, and if x equals 70 degrees, then y also equals 7 degrees. So not too bad there. You're just going to set up this for any type of isosceles triangle problem. If you're missing the base angles, if you're missing the vertex angle, this is how you set it up. Another easy way to think of it is you're eventually just going to divide by 2. You subtract this from 180, and then divide by 2 to get your base angles because they're equal, and you divide by 2 because there's 2 of them to get each angle. Hope you found this video helpful. Thank you so much for watching, and I look forward to seeing you next time on Wes Explains Best.